Hey guys, welcome back to the X-Ring or the Flannel channel. Alright guys, so what we want to do today is at a request of one of my viewers. They wanted to know and they wanted me to do a video on how you determine distance using your reticle. Let's say your rangefinders went dead, or let's say it's foggy out. And guys, there's a ton of information on the internet about this, okay? It's easy to search, it's easy to find, but I figured I would go ahead and do a quick video on how I do it and keep it really simple. Now, there are a ton of different formulas. I'm just going to show you what I use. I'm not saying it is the way, I'm just saying it is a way, and it works for me, okay? So, the most important thing for you to know is what type of reticle is in your scope. It doesn't matter the adjustments of the scope. You just need to know, do you have a mil-radian based reticle or do you have a minute of angle based reticle, okay? Manufacturers will do both. You need to know what you have. You also need to know whether or not you have a first focal or a second focal plane scope. First focal plane, you don't need to worry about what power it's on. As long as you can read the mils, you're good to go. Second focal plane, you're going to have to be on that max power or the manufacturer's recommended power. So let's keep it really simple. Let's say I'm out shooting on a range and I have a 19 by 19 square steel, and my rangefinders just gave up the ghost and they're not working. I know it's 19 inches tall, I know it's 19 inches wide, and I need to know how far that target is, okay? My rifle has a mil-radian based reticle, so I'm going to use this formula on the left here, okay? This is all I want you guys to look at right now. This is all we're concerning ourselves with. To solve using a mil or mils based reticle, what we want to do to determine the yardage is height or width in inches of whatever it is we're shooting times a constant of 27.77, okay? You don't need to know why that number's there. You just need to know that's the one you want to use. You can round up and use 27.8, but if you're doing this, go ahead and do it right. I always use 27.77. You're not going to notice a difference in yardage. It's a negligible amount, but 27.77 is your constant. And what you're going to do is, once you do the height in inches times the 27.77, you're simply going to divide mils for what you've read on that target. I'll make that a little clearer here in just a second. So you've got your 19 by 19 square steel. You've got either a first focal plane or a second focal plane scope. It doesn't matter. We're going to pretend this is full power if you're second focal, and whatever power on first focal, doesn't matter. I've got a piece of cardboard here that's about the 19 by 19. We can either go horizontal or vertical, doesn't matter, but I need to know what my subtensions are on this mil-based reticle. A lot of reticles will have something very simple like this, where these short subtensions are half of a mil and the long subtensions are 1 mil. So it's very simple: half, 1, 1.5, 2, so on and so forth. Same thing vertical. Horizontal, all of it's going to be the same, but you need to know what these represent, what amount, and you can usually go to your owner's manual or go online and download those if you're not sure what those numbers are. So we're going to take our 19 by 19. We're going to go on the horizontal line here. I like to put it on the left side. You put it wherever you like. It doesn't matter which quadrant or anything. It just depends on your positioning and everything else, but you want a good solid foundation. What I do is I place the corner of the target here. Now what I'm going to do is I'm going to read the width of this in mils, okay? Now there's a half, there's 1, 1.5, 2. So we're over 2 mils, but not quite 2.5 mils. So I'm going to have to do some guesstimation here, if you will, because this is a half mil-radian scope as far as these subtensions go. It's not a 2/10 or anything else, it's 0.5. So knowing that we're bigger than 2, but less than 2.5, half of that would be 2.25 or 2.25, but I don't think it's 2.25. I think it's just shy of that. So if I were reading this square steel, 19 by 19, I would estimate this at being 2.2 mils. That's just me if I were looking at this through a scope. So what I do is, that's going to be my bottom here, my divider. So I'm going to take 19, because that's inches, that's on my horizontal, times the 27.77. Then I'm going to divide that number by the 2.2. If you do that, what you're going to come up with is 240 yards. Exactly, it comes out to 239.89 yards, but 240 yards is what I would use on my dope, and I'm probably going to hit center mass on that thing, just dead center perfect. Now, it is very, very important to make sure that you get this calculation correct as far as your mils reading. The closer you are, you're not going to notice that much of a difference, but the further out you get, it makes a huge difference. So the difference between me using 2.2, and let's say you read it as 2.1. Maybe you look at this and you say, hey, you know what, that's 2.1 mils. Well, 2.1 is 251 yards as opposed to that 240 yards. So you're only looking at about 11 yards difference. Negligible. Let's say some of you said, no, I think it's 2.3. Well, 2.3 mils is going to bring us at 229 yards. Once again, 11 yards, 12 yards difference, somewhere in there, about 11 yards. So it's not that big of a deal. However, when you get out further, it gets exponential. All right, guys, so now that you've seen the mil reticle, let's talk about someone that's got an MOA based reticle. And so let's say you've got a circle at 16 inches, and we have an MOA based reticle. This is a very popular reticle. It's a EBR1 MOA reticle. And you'll usually have subtensions that are a little smaller. And then so that reticle has 2 MOA, 4, 6, 8, 10 MOAs. But if we take that 16-inch steel and we put it on our target, now placing it in the corner doesn't work too well on a round, okay? Now you'd be able to see the reticle in front of it, but on a round, I'm usually going to go on a distance like this so that I can see it. And if you look, that's going to come up to exactly 10 MOAs. So if we have an MOA-based reticle, we're going to use this formula to determine the yardage. You're going to take the inches, 16, times the constant, 95.5, divided by MOA, which in this case was going to be 10 MOAs. So the distance based on this is actually going to be 152 yards. Just remember your constants, 27.7, 95.5. Now this is to solve in yards. For those of you that want metric, what I'm going to do is I'm going to expand on that for just a few minutes, and we will continue. All right, guys, so for my viewers in Europe or anyone that's using the metric system, the formula, everything works the exact same. You still have to know whether or not you have a mil-based reticle or an MOA-based reticle, but it's very simple. So if you have a mil-based reticle, to determine the meters, the distance in meters to how far you are from your target, what you're going to do is you're going to take the height or width of your target in meters times 1,000, and you're going to divide that by your observed mils, just like we did on the other formulas. Now, a lot of you guys might be saying, well, you know, smaller steels, this can be hard to measure it in meters, it might be centimeters. Well, it's really, really simple. If you're trying to determine for centimeters, all you use is 10 as your multiplier. So in that case, if you're trying to solve for centimeters, it's going to be meters are going to equal the height or width in centimeters times 10 is your constant divided by mils observed, okay? So that's going to be your formula for meters with a mil reticle. For those of you that are in, for whatever reason, let's say you're using an MOA reticle and you want to solve for meters, what you're going to do is you will use, to determine the meters, you will use once again height or width in meters times the constant 3438. 3438, and you're going to divide that by the observed MOA. Now, once again, if you're trying to solve for centimeters, the distance you're trying to determine is in meters. You're going to do the height or width in centimeters, and this is pretty simple. Now you're going to use your constant 34.38 and divide that by your MOAs. So that's how you're going to solve for meters, whether you're on an MOA-based reticle or a mil-based reticle. I didn't know so many guys were going to ask for that, so because of that, I've modified the video. I've also made some corrections, but everything's going to work out the same. So whatever system you want, or if you want to write down all the formulas, that's fine, and you have them. It's good to know information, but they're pretty easy. So for the guys that are trying to solve in yards, just remember that 27.77 for mil-based. For the ones that are trying to solve in yards with an MOA-based, your constant's going to be 95.5. For meters here, it's either going to be 1,000 or 10. And for your MOA-based reticles to solve in meters, it's going to be the 3,438 or 34.38, depending on if you want to use centimeters or if you want to use meters. All right, guys, so we're going to get started by showing you a view of a scope. And the scope that I'm going to show you first is a second focal plane scope. What I'm going to do is I'm going to go from the minimum power to the maximum power while you guys are seeing it through the reticle, and I want you to pay attention to the target size or the zoom. But more importantly, pay attention to what the reticle does, okay? Here we go. All right, guys, so in this first example, this is a Night Force ATAC-R, but it is a second focal. We have it on 5 power right now. What I'm going to do is I'm going to zoom it from 5 power. If you guys can see the reticle there, you'll notice that it does not change size. Only the picture is changing size. So this is going to make it a second focal plane scope. All right, guys, so in this next example, what I'm going to do is I'm at 4 power right now. And as I zoom in, pay attention. If you can see it, I want you to look at the numbers there within the reticle. See how they're getting larger and larger at the bottom? So as the picture changes, so does the reticle. So right now, sorry, I'm trying to hold it still. Right now, you can actually see those dots there, but as we zoom out, those dots get smaller and smaller and they kind of disappear into oblivion. Well, that's kind of normal with a first focal plane scope. You can't see it on the lower power. Here for you guys to see this on a white piece of paper. You guys can see how as it goes down, you might be able to read those numbers. But as we zoom out, those brackets are going to get smaller and smaller and smaller. So even though we're zooming the picture, what we're also doing is we're changing the size of that reticle for our viewing. So that is a front or first focal plane scope. All right, guys, so for this next one, this is a Night Force with the Trimmer 3 reticle. Now, we are ranging the little small pepper popper, the little silhouette, underneath the 9x9 steel. I'm going to get it out of focus just a little so you guys can kind of see that reticle. And on 16 power, that actually gives me a reading of 1.2 mils. Now, I am sure of that. I know it's a 4-inch steel, so I'm going to take 4 times 27.777. I'm going to divide that by 1.2 because that's the width of the steel that I got, and that's going to bring it out to approximately 93 yards. All right, guys, so that exact math ended up being 92.59 yards. And when I hit it with the rangefinder, it was actually 91.5 yards. So you can be very, very precise. You don't need the long distance to practice this. You just need to know your equipment. All right, guys, for those that stuck around, I hope you enjoyed that little visual there towards the end. If you guys have any questions, please put it in the comments below. Otherwise, like, share, and subscribe. Appreciate you guys watching the channel. Have a good one.